What we do know is supplementation appears to be really the most robust way to increase intramuscular levels of carnosine. And you have to do it with fairly moderate to high doses of beta-alanine over 4 to 6 week periods to see changes. So it's definitely a bioaccumulation effect. And you have to have pretty meaningful doses. So generally, recommendations from the exercise science literature is about 5 grams a day to see an actual meaningful effect or increase. And it's about 4 to 6 weeks before you actually see anything meaningful.
humanOS. Learn, master, achieve.
In this episode of humanOS Radio, I'm talking with Brad Dieter. Brad has a PhD in exercise physiology from the University of Idaho. He is a scientist, a coach, an entrepreneur, a writer, and a speaker, so he wears a lot of different hats. He has also been working as the director of science at Harness Biotechnology. On my show with Jeff Rothschild on ergogenic aids, we discussed the popular supplement called beta-alanine. Athletes need to take beta-alanine 4 times a day for weeks to increase carnosine stores in order to get the ergogenic or performance-enhancing benefit. Topical application, on the other hand, has the potential to immediately boost carnosine stores, and horses who are administered carnosine are able to run faster race times, exhibit longer stamina and endurance, and are able to recover more rapidly. If it works in equine athletes, could it also work for humans? The answer to that question seems to be yes. LactiGo is a fast-acting topical gel that delivers carnosine to muscles through the skin, and tests of this product are pretty persuasive. In one double-blind placebo study, soccer players who used LactiGo before running the 40-yard dash were meaningfully faster, and this was just after a single application. Brad is the person to talk to about the performance-enhancing effects of topical carnosine, which is why he is here today. So, Brad, welcome to the show.
Hey, Dan, thanks so much for having me on. It's kind of surreal talking to you. I've been a big fan of yours. Looking forward to the conversation. Thanks for having me on.
Oh, that's nice of you to say. Tell the audience more about your background.
After undergrad, I started a master's program and I worked primarily in biomechanics and neuromuscular control. During that time, I was taking a couple advanced physiology classes and got really interested in molecular biology and molecular basis of disease. And so I spent my PhD work doing that and really got pretty interested in novel approaches to A, treatment, and B, delivery of drugs or molecules for disease states. So I primarily focused on metabolic diseases, primarily diabetes and organ complications. Did a lot of basic science, machine learning, and as we were trying to find new targets and new drugs. Along the way, I stumbled into being more involved in industry, whether it was from the technology side or from the biotech side, and launched my career into industry and entrepreneurship. And that's kind of where I am today. So I've got a background in quite a few things. And some of the more interesting stuff is I've been able to do a lot of comparative physiology, which has been pretty interesting. So I've worked in humans, rats, mice, grizzly bears, horses. Pretty interesting animals I've gotten to work on. And we've learned a lot from comparative physiology. So that's been really cool as well.
And now you've been directing research on transdermal carnosine at Harness Biotechnology. How did you get into this specifically?
A good friend of mine approached me back in 2015 and was talking to me about this way of delivering carnosine that was a lot more efficient than traditional uses. We traditionally try to increase intracellular levels of carnosine through beta-alanine supplementation, right? We know that carnosine is beta-alanine and histidine, so 2 amino acids that in your muscle tissue will be joined together with an enzyme to make carnosine. And traditionally, we thought that was the only way to do it because most of the investigations of orally consuming carnosine didn't work. First, it's broken down in your GI tract. And then second, when it does get absorbed into your bloodstream, you have an enzyme called carnosinase, which is the enzyme that actually takes carnosine and breaks it into beta-alanine and histidine, the 2 amino acids. And then they don't end up in your muscle tissue very efficiently. And so you can't really orally supplement with carnosine efficiently. So we would have to take it orally using beta-alanine and hope that over time, if you take enough beta-alanine, your body will augment its carnosine stores based on just what we know about stoichiometry and basic biochemistry. I was approached from somebody probably, I guess it's been 5 years I've been working on this now, a potential way to deliver it more directly. bypass circulation and get it into muscle tissue more efficiently. And I was, I guess, like most people and most trained scientists, was very skeptical. And we started working through the delivery approach, some of the preliminary data we had from cell culture models and 3D culture experiments that were done, and it looked very promising. And so we kind of continued marching down the path. And now we are where we're here today, about 5 years later.
So what carnosine is the combination of beta-alanine and L-histidine, two amino acids. While supplemental carnosine is sold, it's not an effective way to increase muscular carnosine levels because it gets broken down both through the digestive process and also then in the bloodstream. So that doesn't work. Rather, athletes have been taking beta-alanine, which is one of the two amino acids that is involved in carnosine synthesis. And over time, we can see that it does increase carnosine levels in the muscle. But up until now, that's been the only way to really increase carnosine levels supplementally. What are some other factors that actually determine carnosine content in muscles? And where else is carnosine found? Is it found in other organ systems as well, or is it stored intermuscularly mostly?
Yeah, that's a great question. So it's found in most cells in your body. It's in a lot of your neural tissue, even your skin cells have it. It's in your digestive tract. It's in pretty much every cell in your body, because one of its main roles is to be an intracellular buffer, right? So we usually think of like sodium bicarbonate as a buffer, and that's kind of our extracellular or our in our blood buffer. And carnosine is the intracellular buffer. One of the primary ways that we maintain acid-base balance inside our actual cells, not just circulating through our body. So it is all over the body. It's found in most tissues, but the relative concentration is different, right? So we know that cells that require more acidotic processes, like are very heavily glycolytic, we know that you're probably going to have higher concentrations. And when we do comparative anatomy studies and we look at carnosine concentrations across different animals and different organ systems, and we see that metabolic demand matches carnosine concentration. So we see it in humans. Some of your highest concentrations are in some of your large muscle groups. We definitely see it in horses. There's like a 30 to 40 fold higher concentration in gluteal muscles than the organ systems in a horse. So we definitely see the metabolic demands match the concentrations.
Interesting. And we see them not just in muscle, but also in different muscle fiber types. So if I'm correct, type 2 fast twitch muscle fibers contain a higher amount of carnosine than the slower twitch type 1.
Yeah, so there's like across organ differences, there's within organ differences, especially in muscle tissue based on fiber type. In the brain tissue, depending on cell type, there can be some differences in concentrations as well.
I want to ask also about some factors that determine carnosine in muscle. So things like age, diet, gender. We talked about training. What else do we know?
Yeah, so one of the big ones is genetics. We know that there is a pretty big bell curve of carnosine concentrations across the average human. So genetics can play a big difference in that. One of the hard parts is it's hard to do real good genetics on athletes and get good data that isn't confounded by exercise. But we do tend to see the elite of the elite athletes generally have higher levels of carnosine. And we think some of that is obviously training induced and some of that is just genetically. So genetics play a role, and then buried in that are things like gender is obviously genetically controlled. And then diet definitely can impact carnosine levels, whether it's you're not consuming very much beta-alanine and histidine in your diet or you're consuming a lot naturally. Those things can make a difference. Age for sure. Now, whether that is due to genetic control with age or its overall physical capacity plus lack of diet, we do know that age generally is associated with lower levels of carnosine. And then training status. We do know that there is a training effect of, whether you are a trained athlete or an untrained athlete, your baseline levels of carnosine. So those are some of the big things that we know can predict or change your baseline levels.
What do we know about optimal levels from diet? So let's say you're on a paleo diet, since that contains more carnosine precursors for carnosine stores in your muscles, and what you might attain or achieve with supplementation. What's the difference there?
There's not a lot of good observational research of what types of dietary patterns associate with the highest levels of intramuscular carnosine. We don't really have good data from that. As far as I know, there's been no systematic biopsy studies done across a panel of people on different diets. So I don't know if we have great answers on that. But what we do know is supplementation appears to be really the most robust way to increase intramuscular levels of carnosine. And you have to do it with fairly moderate to high doses of beta-alanine over 4 to 6 week periods to see changes.
Yeah.
So it's definitely a bioaccumulation effect, and you have to have pretty meaningful doses. So generally, recommendations from the exercise science literature is about 5 grams a day to see an actual meaningful effect or increase. And it's about 4 to 6 weeks before you actually see anything meaningful from beta-alanine supplementation.
That's a long time. 4 times a day for 6 weeks. It's achievable, but a lot of people won't be able to stick with it.
We're all instant gratification creatures. So if you have some slow loading molecule like that, you're probably not going to mentally notice it if you're slowly increasing it over, 6 weeks. So I think a lot of times people don't feel an effect after 2 weeks, and then they don't feel it after 4 weeks, because it's kind of like the analogy of the frog in the pot of water that you slowly heat up. You just don't really notice it. So you don't think about if it's being effective or not.
I created a term for that, the meaningful but invisible.
Yeah.
And it can happen in both directions. So you can take something, it's having an effect because it's happening slowly. You acclimate to the benefits along the way since they're so gradual. And now maybe you're getting a 15% improvement in whatever parameter you're looking at, but it's harder to notice because it took that amount of time to achieve it. And vice versa. You could degrade over that same amount of time and also not notice that decrement in performance. Whenever things have a slower time course for changing, it is harder for us to see. So you talked about bicarbonate as a way to buffer hydrogen ions in the blood, and how beta-alanine or carnosine is a way to buffer hydrogen ions intercellularly. Let's talk a little bit more about that process and how that works in the course of exercise so people can grasp when this is having an effect.
When you're exercising and you increase the intensity of your exercise, or even you're at a moderate intensity for an extended period of time, your body starts using glycolysis quite substantially to produce energy. And one of the big byproducts of that is hydrogen ions. So hydrogen ions are what give us acidity. Greater hydrogen ion concentration, the more acidic things are. And carnosine generally acts as, the analogy I like to use is like a molecular sponge. It soaks up the free hydrogen ions and binds them. When you start to saturate your carnosine stores, you start to produce free hydrogen ions, and then that works with a pyruvate and lactate part of your body. So the hydrogen ions get sequestered by the lactate, and then generally what happens is your body will export that out of your cells into circulation. And then the lactate and the hydrogen ions will disassociate, and the sodium bicarbonate will do its job to manage the acid base in the body, and you will breathe out some of the acid, and then the lactate will get recycled. So really, if we think about it, carnosine is one of the very first steps of acid-base balance, and that occurs inside your cells. And then when acid starts getting exported out into the body, sodium bicarbonate is the spillover that manages what's pushed out of your cells. So we have 2 different compartments and 2 different steps in the process. So one is first and one is second.
When you're producing a lot of lactate, that actually seems to be an important signal for the training benefit. Tell us what you know about that.
There's probably people who know quite a bit more about the lactate and exactly what signaling aspects that does than I do. But we do know that, one, the lactate threshold really gives us an idea of how much work capacity you can do before you become very highly anaerobic. So that kind of gives us an idea of what is your physical capacity of your body in terms of work output to oxygen consumption and anaerobic activity. That's generally one of the markers we use for people who are training and trying to see if they're improving their overall fitness. So if you reach your lactate threshold at a normal wattage on a bike, and then 6 months later, your wattage is higher before you reach your lactate threshold, your physical fitness has improved. So that's one of the markers we use. And then lactate itself, like you mentioned, cannot actually be a fuel source. So we can actually recycle it and use that for fuel during exercise as well.
Now, to hone in a little more specifically about the types of athletes that would benefit from trying to augment carnosine stores, would an ultra endurance athlete benefit because the race is so long, or is it really more just sprint style athletes? Where do you draw borders on who you think this will work best for and who it also might work for?
This is kind of one of those questions that we have started to collect more and more data on from the athletes that we worked with. We've seen pretty impressive results, obviously, amongst our highly explosive anaerobic repeated bouts athletes. So mixed martial arts fighters, sprint athletes, basketball players, football players, hockey players. So people who are doing cyclical, high intensity interval type of training. And then we've also seen a really big benefit in long endurance athletes. So we've seen Ironmans, ultra marathon runners, people who do multiple back-to-back day events. We've seen pretty substantial benefits in their performance and their recovery. And what we really see is, especially in the cycling and running events, is the drop-off in performance over time. That drop-off is much slower and much less than what we see in without something like that. So that's generally what we've noticed. And that parallels really well to the beta-alanine literature, which is what we would expect to see.
Let's talk more about the product LactiGo, the transdermal or topical application of carnosine. It comes with and without menthol. How do you get it across the skin and into the muscle? And where did that idea come from?
Currently, the product that we have available is the formulation with menthol. We've done that for several reasons. One is we've noticed that it is more effective at delivery. Two, there is some benefit to it in terms of how we use it with our athletes in terms of recovery and then how we deliver it. So based on what we know from our 3D culture studies that we've done in the lab in vitro, and then the human studies that we have done as well, is the carnosine is primarily driven across through the fact that we have it conjugated with another molecule that works synergistically with it to drive it across. The carnosine and magnesium that we have in the product work together synergistically to facilitate the delivery across the skin. We saw that in the 3D culture study that we did, and we also have seen that in our human study as well.
As opposed to beta-alanine, where you have to dose this 4 times a day for 4 to 6 weeks before you start to see the accretion of carnosine in the muscle, how quickly do you think that this is working, the LactiGo?
We actually have kinetic data from a study we did in horses. So we actually used horses as a model for a couple of reasons. One is horses have some of the highest levels of carnosine in their muscle tissue of all animals on the planet. They rely on it very heavily. So if they're kind of already at their genetic maximum, essentially, of what they're going to naturally produce, we thought it would be interesting to use them as a preclinical model for, okay, if we take an animal that's already relying on this and we try to get this product across into their muscle tissue directly, that's probably going to be the least likely animal to see a big increase.
Right.
And so what we saw was within 60 minutes, we had substantial increases. We're talking in the magnitude of about 50% on average in the horses. Some animals, we saw increases as much as 100%, and we saw some with 20-25%. That was where we were comfortable. Within about 60 minutes, all of the horses saw some increase between 20 and 100% with an average about 50. At 30 minutes, we did see, instead of dose response curve, a time response curve where 30 minutes, things were increased, 60 minutes, things were definitely increased. And at about 2 hours, we started to see the increase taper off. It hit probably just past max capacity.
Fascinating. A big part of the conversation I had with Jeff Rothschild in the Ergogenic Aids podcast recently, if these things are effective at performance enhancement, should I be taking them all the time? You could envision that something was actually helping you perform better right now, but was also inhibiting the signals that are induced by exercise that then enable you to get better from the work that you're putting out. And so that's what caused him to take a deep dive into that subject. Similarly, here, if we're causing more buffering of hydrogen ions, you could see that a person could work harder. But do we know anything about how this might change muscle fiber type or anything about the accretion of gains from training through the use of this product? What are some of the longest term studies that we have with beta-alanine or with LactiGo?
Those are very good questions, right? And a friend of mine always says there's no give without any take. There's a few ways to attack this question. One is from the theory standpoint of what is this actually doing and what would we expect? What is the data we have on this molecule itself? And then what is data we have on similar approaches that have the same end effect? If we really think about what this is doing, fundamentally what it's allowing you to do is produce more work at a similar metabolic load as you would without it. How does my body respond to additional workload? with the same metabolic strain, we'll say, as a lower workload. Well, it should, in theory, cause me to have more adaptation to the workload. The converse of that is not having the metabolic strain as high as it would be at that workload detrimental. So when we look at the beta-alanine literature itself, the longest studies we have in that are somewhere in the neighborhood of 4 to 6 months. Mm-hmm. And we don't really appear to see any negative effects from beta-alanine supplementation in terms of work capacity, in terms of training adaptations, in terms of metabolic changes. We don't appear to see any of those. Now, longer term, could there be something? It's possible. Looking at how the body adapts to changing workloads and what role we know that metabolic acidosis or oxidative stress that might occur from it when you manage it during exercise in the manner that we're doing it, doesn't really appear to have substantial negative impacts that overcome the benefit we get from the additional workload.
Right.
And creatine works similar in the fact that the way it works is it allows you to produce extra work capacity. Different metabolic systems, but same end result of extra work capacity. And those studies have been a little bit longer term than beta-alanine. There's been more studies shown, and we also don't see any sort of interference training effect over the long period. So those are the three ways I would ask that question. And from what I can glean is currently we don't think that the pros come with the types of cons that might mitigate the benefit.
How you would then use this product going forward in terms of figuring out the ideal protocol. Do you want to do some training without it? Do you want to do some training with it? Do you want to do all training with it? I'm so glad we're at the point where we can ask these questions. Let's now look more closely at work in humans and what we've seen when LactiGo was used. There's a soccer study that I'd love for you to talk about. So tell us about that study. Who was studied and what was the protocol like?
Yeah, so that study was actually led by two colleagues of mine, Chad and Tim. They led the charge on that piece. What we did with that is we took soccer players and we actually had them either use a placebo or the Carnosine product. And we had them do a series of events or experiments. We had them do a yo-yo run test, which is a interval training type of test. We also had them do some additional longer duration work. And what we were really interested in is how does this affect their anaerobic recovery capacity? So if you have a system that's producing a lot of hydrogen ions, would this actually help them with the recovery and the sustainability of their repeated bouts? And so we did these in highly trained professional soccer players, right? So these are the people who have probably already at their limit of what they're capable of. So can we take that and expand on that? And so that study, we were able to show that this actually does exactly what we think it does when we put this in the field.
CrossFit athletes probably be a perfect athlete to benefit from this, given the demands of their sport, which are unpredictable in that every day is a little different, but usually very high intensity. So that would be a good fit there.
Yeah, it's very much a sustained sprint, rest, recover, sustained sprint, rest, recover sort of sport for sure.
Bodybuilding, where the shorter rest periods and high volume. Powerlifting, maybe not so much. That might be entirely phosphocreatine, but who knows? It might be interesting to try there too.
Yeah, especially their rest period recovery, what's going on metabolically there. We have done some other investigations. We've looked at exactly how this might affect cramping. We've started some investigations on delayed onset muscle soreness. So these are some of the other questions that are related to the metabolic aspects of exercise. What do we know about what this does for those pieces? And so we're excited to get some of that data in and figure out what other things we can learn.
Well, let's talk about how to use this then. When do you apply it and how many times do you apply it?
It really is individualized answer. At this point in my life, I would very much qualify myself as like the weekend warrior. I think my professional or aspiring professional athlete hopes at this point are fairly shot. So I use it before I do any sort of major event, like if I'm going out for a long bike ride or I'm going to play basketball or I'm going skiing or anything that's like a pretty high metabolically demanding activity. I'll use it and I'll put it on anywhere from 30 to 60 minutes before. That's generally the time frame that I'll use it and apply it. If you are a higher volume athlete, there's kind of two pieces to it. One is there's the acute usage of right before you train. And then the chronic piece, using it a couple times a day just to augment the baseline levels as well. So if we have athletes who are training 2 or 3 times a day, or they're professional athletes, we'll have them use it right before they actually compete or they train, but then we'll also have them use it usually first thing in the morning and right before they go to bed as well.
Because you can get carnosine levels elevated right away, does LactiGo itself even have a loading period? So let's say you're training maybe 3 times a week. Do you only want to use it prior to training, or do you actually want to use a little bit every day? And then how long do the elevations last for?
Based on the data we have so far, and we still need to do some more investigations because we don't have all the answers quite yet, but we do know that we probably reach a peak right around 2-ish hours, and then we start to see some decline around there. And I think that depends on your utilization. You may see quicker declines if you're running an Ironman or competing in an Ironman. You just have a high metabolic workload. You're probably going to need to use it every 2 hours. Whereas if it's like, hey, I'm just out hiking or skiing and I don't have a huge metabolic load, that decline's probably slower. So we do see that you probably reach peak and then a slow decline at about 2 hours is kind of where that starts.
And what about if it's really hot outside and you're in a humid environment and you're sweating a lot? Does that affect its absorption?
We don't think so. The way it's formulated is it's got some additional cosmetic ingredients in it that help manage the sweat and the moisture. And it starts getting absorbed pretty quickly. So as long as you're not super sweaty and not giving it a couple minutes to dry and start the process, it shouldn't affect it too much. Now, if you are like super sweaty and you're putting just a tiny little bit on, it may affect it.
So I have to say that I noticed it from the first application. I've only had it for a few days, but I've tried it twice. Near where I live, there is a famous set of stairs called the Dipsea Stairs. And it's part of the Dipsea race, which is a 7-mile race from Mill Valley out to Stinson Beach. And they do it once a year. The very beginning of that race is a set of 700 stairs and 3 flights.
A lot of stairs.
A lot of stairs, yeah. You walk up it fast, you're going to feel it. So I put it on before that, and that was the challenge that I thought would be perfect. And my legs definitely felt better on the way back down and even towards the top. I felt more fit than I am.
It's pretty crazy when you can use something and actually notice it immediately, especially being very skeptical people in general. You're like, oh, this actually works. One of the interesting things I've had a lot of my friends do is just put it on one leg. Just put it on one side and go to a leg workout or go on your bike ride and just notice the difference. Because then that kind of helps them, be like, oh, is this a placebo effect or not? And it's like, well, if you put it on one leg and not the other and you notice a major difference, you'll really have an idea of what the difference is.
You guys were calling that the LactiGo Challenge.
Yes, that's kind of our social media shtick. Came up with something clever so we could get people to try it and use it that way and then kind of share their stories with us.
It's a great idea because we talked about the meaningful but invisible concept earlier. If you could detect a real difference within one workout, you could become a convert for life.
It's crazy how many stories and emails we get from people or text messages. And when you give it to somebody and you convince them to try it and we're like, where do I order the rest of it?
Yeah, that's great. Do you have other products that are in the works? Or are you also looking to increase the product line for the company?
I have a very keen interest in, because of my background and what I've been focused in is how far does the rabbit hole go with what we can do with this delivery of carnosine and the potential research around what carnosine can do, not only from a human performance perspective, but from a health perspective. Our science team has a lot of interest in doing additional clinical work on that for some acute metabolic conditions, for some chronic ones that we are really going to try to go after over the next 30, 40 years of my science career. We've got a lot of work cut out on that aspect. And then we also have intentions and thought processes around what else can we do. Carnosine it's the intracellular buffer. What other components could we add with that would augment it even more? And so we have some ideas around it with some products that we're currently developing that we're hoping to make what's already a very effective product more effective.
Now, because it's an effective ergogenic aid, how do governing bodies view LactiGo? Is this banned anywhere, or is it something that people are open to using?
It has the NSF informed choice certifications or designations. Your body naturally produces it. It's treated very similarly to creatine. It's not banned in anywhere. Is completely clean on a blood test, right? So we've tested every athlete you can possibly imagine at the highest level. The horses that we've applied it to have been tested after some of the largest events like the Kentucky Derby. So it's completely safe, effective product. That's been the biggest concern of ours from day one. Is this is a very natural product, and the fact that you're increasing one of your body's natural capacities a little bit more. And so how do we keep this within that realm?
Brad, thank you for coming on and telling us about this product and doing all the hard work to develop it. And that's going to, of course, continue. But it's so exciting to hear about it. And at the end of the show with Jeff Rothschild, after we went through supplements that have some of the best evidence behind them currently, I said, are there any products that are coming onto the scene that you're excited about? And he mentioned LactiGo. So that made me reach out. And I was very pleasantly surprised to hear that you were at the company, since I already knew of your work.
I'm very honored to have been here. Big fan of yours and really enjoyed the conversation. And we feel very fortunate to have a platform like this. And I take a very, very, very small amount of credit. We've had a big team that's done a lion's share of the work and handled a lot of the logistics and back end and a lot of the early days work to get things put together. So we're very fortunate.
Where can people go to learn more and to get the product?
LactiGo.com is the best place to go learn more. We should have links to most of the scientific pieces that are on there. Any of the unpublished work will always be posted up there as soon as it gets the clear by regulatory that we can post it. We're super transparent in everything that we do. Our ingredients, our scientific inquiries, our papers, all that stuff is available there as well.
Perfect. Well, thanks again, Brad. We look forward to seeing what comes next from your company and how athletes, even recreational ones, use it in time. We love that this is now an option in our world. What a cool thing. If you can make exercise a little bit less painful, more people might do it.
That's also very true.
Thanks for listening, and come visit us soon at humanOS.me.